Hello. In the previous video, I've shown you that how we can add two vectors by using head to tail rules. Now we will study how to add two complex numbers. So we suppose that there are two complex numbers, z1 and z2. The first one is a plus b iota. The second one, suppose it is c plus d iota. Then their sum is just z1 plus z2. Okay, so how can we add them? Just place their values first. Z1 is a plus b iota and z2 is c plus d iota. Okay, so plug their values and then break the brackets. A plus b iota plus c plus d iota. Now first of all we will add the real parts. These are two real parts. This is the real part. The real part of this is a, the real part of this is c. Okay, we will add the both real parts, a and c. It will be a plus c. Okay, then look at the imaginary part of both. This is the imaginary part of the first one, this is the imaginary part of the second one. So add them both. B plus d iota. I will write b plus d iota. What I have done, I have just added the real parts of both and then imaginary part of both. So this is just the sum of two complex numbers. Okay, now look at the geometric interpretation of this sum of two complex numbers. So we will again assume that we have two complex numbers, z1 and z2. Then we can use graph to add both of the numbers. Okay, let's look at the graph. So first of all, I will write a plus b iota. So this means we will represent a comma b. So a is along x-axis this way. Suppose this is a, okay, and b is along y-axis here. Suppose this is b. Then what is a comma b? So in order to find a comma b, I will draw two perpendicular lines. This line, okay, this line and this line, passing through both points, and this point is the point of intersection. Okay, so now I will write a vector. I will draw the vector just whose tail is at the origin and whose head is towards the point. And now suppose that we have c plus d iota, because we have two complex number, a plus b iota and c plus d iota. Okay, let's this. So first of all, write into an ordered pair. Suppose, okay, this is along x-axis, along horizontal line. So suppose this is c, okay, and suppose this is d somewhere. Okay, so first of all I will draw the vector representing both. So first of all I will draw two lines, this line and this line. Okay, so this is the point of intersection of both. So this is actually CD. So I have drawn a vector just whose tail is here and whose head is here. Okay, so these are two vectors which are represented which represents two complex numbers, a plus b iota and c plus d iota. Now how can we add them? Graphically, geometrically, if we add both of the complex numbers, what we have to do, we have to shift one vector from here to what we have to do, we have to shift this vector here, right? This is what I told you previously, right? Okay, so so I will not shift it, I will just make its copy here, and this copy, this is the copy of this one. Okay, I will just write its copy here, and now I will draw a new vector starting from here and ending at here, right? Okay, so this new vector is called the resultant vector. So I will call it resultant, which is actually z1 plus z2. So this is the geometric interpretation, right? So make sure that this vector is not the original vector is this one. But why I have shifted this vector here? Just in order to apply the head to tail rule. Now look at this example. Add these two complex numbers. Okay, here is the solution. We are given two complex numbers, this one and this one. We have to add them. How can we add? First of all, I will write the first complex number, then I will write plus, and then the second complex number. So first of all, I will break the brackets. Okay, I break the brackets. And now I will add the real parts. What's the real part of this? Is 1. And the real part of this is 4, negative 4. So I will add 1 and negative 4, okay? 1, negative 4. Plus the imaginary part of this is 3. The imaginary part of this is 7, okay? So I will add 3 and 7. 3 plus 7 times iota, because both are imaginary parts, so I have written iota. 1 minus 4 is minus 3. 3 plus 7 is 10 iota. So this is the answer. Okay. So there are some properties of the complex numbers. If z1 and z2 are the complex number, for the set of complex number, I use this notation C, okay? The first property is either you add z1 into z2 or you add z2 into z1, you will get the same answer, okay? Just like either you add 5 in 2 or you add 2 in 5, you get the same result. So just like real numbers, this is called the commutative law. The commutative property, this is called the commutative property. So I have written commutative. The second property is, if you have three complex numbers, z1, z2, and z3, then we have associative property of addition also. z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. What does that mean? Here you have added z2 and z3 first, and then you added z1. But what have you done here? Here you added z1 and z2 first, and then you added z3. So either you add any two numbers first, and then you add the third one, you will get the same result. This is called the associative property. Okay, look at the last property. The last property says the zero an element, which is called the additive identity. This is also the element of the set of complex number. This means 0 is an element of set of complex numbers, and for all other elements of the complex numbers, we have z plus 0 is equal to 0 plus z is equal to z. Either you okay, what does it means? It means if you add 0 to any complex numbers, either from the left side or from the right side, you will get the same complex number. Just like when you add 1 plus 1 into 0, you get 1. Either you add 0 into 1, again you get 1. Just like this. This property is called the additive identity, or we call it neutral element. So 0 is called the neutral element because it doesn't change the number. Okay, I have added 0 to z, but it didn't change z. we get back z. Okay, so that's why it is called neutral element. Next we have an opposite of a complex number. What is meant by this? If we have two complex numbers, for example z1 and z2, if we have two complex numbers and we say that z1 z2 are opposite to each other if and only if their sum is 0. If and only if z1 plus z2 is 0. Okay, what is meant by this? It means z1 must be equal to negative of z2, because if you take z2 here, it will be negative. That means two complex numbers are called opposite if one is the negative of the other. For example, what's the opposite of 1? It's negative 1. What's the opposite of 1 minus 3 iota? It's negative 1 plus 3 iota. The opposite of this is this one. Okay, because this is plus, you make it negative. This is negative, you make it plus. Okay, so this way you say that two numbers are opposite of each other. Now let's look at the difference of two complex numbers. The difference of two complex numbers is just like the sum of two complex numbers. So if you what is the sum of two complex numbers? If you have two complex numbers, then their sum is z1 plus z2. If you need the difference, you will write minus instead of plus. So if you have minus here, then you will have minus here, right? So if you have minus here, then this one should be minus and this one should be minus, right? So then you will have a minus c instead of a plus c. Here you should have minus. And similarly, you will have b minus d instead of b plus d. Okay, so this is called the difference of two complex numbers, right? So I will write, if you have two complex numbers z1 and z2, then their difference is z1 minus z2 equals to the first complex number and minus the second complex number, right? Now you will break the brackets. First of all, you will write this one as it is, and then this minus c and then minus d iota, right? Because when this minus will be distributed inside, so it will be minus c minus d iota. Now let's check what are the real parts. This is the real part and this is the real part. So you will add both of the real parts. And then what are the imaginary parts? This is plus b and minus d. So you will write b minus d iota. Okay. So in this way you can have difference of two complex numbers. So let's look at an example. So we have two complex numbers, 1 by 2 plus 3 iota, and another complex number, we have to subtract them, minus 4 plus 7 by 3 iota. Okay, so how can we have difference? So first of all, write this complex number as it is, 1 by 2 plus 3 iota, and then distribute this minus inside here and here. Okay, so this minus and this minus will become plus 4, and this minus with this plus will become minus, because minus plus is minus, 7 by 3 iota. Now you will add the real parts and the imaginary parts. Real parts are without iota, this one and this one. So it is 1 by 2 plus 4, and then the imaginary parts are the numbers along with the iota. So it is 3 minus 4 by 3. Plus 3 minus 7 by 3 with iota. Okay. Okay, now add both of them. So let's check what is the numerator and what is the denominator. The numerator of this is 1 and the denominator is 2. But here the numerator is 4 and the denominator is 1. So we should make the common denominator. You check. The denominator of this is 2 but the denominator of this is 1. We should make the denominator same. How can we make the same? 4 by 1, we will multiply this with 2 and divide with 2, so that here we also have denominator 2. Okay, because here the denominator was 2, so I have multiplied and divided this term by 2 so that we get the same denominator here. Okay, because 1 multiplied by 2 is 2. Similarly, do the same thing with this one. Let's look. Here we have 3 by 1. So we should make the common denominator. What will I do? Because here the denominator is 3. So I will multiply this with 3 and divide with 3. Minus 7 by 3 iota. Okay. Here you have 1 by 2 plus multiply these two terms. It is 8 and multiply these two terms, it is 2 plus it was 3 by 1. Okay, multiply these two terms, which is 9. Now multiply these two terms. 3 times 1 is 3. Okay, so minus 7 by 3 iota. Now the denominators are common. Okay, I can write the common denominator once and then I will add 1 and 8. So 1 plus 8. Also here the denominators are common. So I will subtract 9 minus 7 because inside you have minus. You will write 9 minus 7. Okay, now 1 plus 8 is 9 by 2 plus 9 minus 7 is 2 by 3 iota. So this is your final answer.